So, Apache Kafka. You've probably heard that name buzzing around, right? Especially when people start talking about big data or microservices. Well, today, we're going to pull back the curtain and figure out what it's all about, in plain English. But before we get into what it is, let's talk about why it even exists. I mean, what problem is it really trying to solve? Picture this. You've got hundreds of different apps, all needing to talk to each other, all needing the same fire hose of data. How on earth do you connect them all without it turning into a complete mess, especially when you need it to be fast and super reliable? That's the big question. So here's our game plan for today. We'll kick things off with that data challenge. Then I promise we'll use some really simple analogies to make it all click. From there, we'll get into the nitty-gritty, the core building blocks, how data actually moves around, what makes Kafka so special, and finally, the big one, when you should actually use it. All right, first stop, the modern data challenge. You know, back in the day, things were kind of simple. You might have had one big application talking to one database. Easy enough. But fast forward to today, we've got microservices everywhere, dozens, sometimes hundreds of them. And if you try to connect them all directly to each other, wow, you end up with this insane spiderweb of connections. It's a total nightmare to manage. What you really need is something more like a central nervous system for all your data. And that is exactly where Kafka comes into the picture. Now, to really wrap our heads around this, we are not going to start by throwing a bunch of technical terms at you. Nope, we're going to start with some simple analogies to make these big, abstract ideas feel a lot more real. Okay, here's our main analogy, and it's a good one. Let's imagine Kafka is like a big city's central post office. Seriously, stick with me here, because this is a fantastic way to see how all the different parts work together. And this is where it all starts to make sense. So you've got people dropping off letters at the post office, right? In Kafka, those are your producers. They're the apps creating the data. And the PO boxes, you know, the ones labeled payments or user clicks, those are your topics. Then you have the mail clerks who all work together to sort through the mail. That's a perfect picture of a consumer group. And the whole post office building itself, the physical place where everything happens, that's your Kafka broker. See? It lines up pretty well. Okay, but the post office analogy isn't perfect. Think about it. Once you pick up your mail, it's gone from the PO box. Kafka has a superpower that this analogy doesn't capture. So let's try another one. Think of Kafka as an endless shared CCTV recording. Your producers are like cameras, constantly adding new footage to the tape. But here's the magic part. Anyone with permission can watch it. You can watch it live as it happens, you can rewind to see what went on an hour ago, or even start from the very beginning. And the best part? You watching the tape doesn't erase it for anyone else. This idea is a total game changer. All right, now that we've got those analogies floating around in our heads, I think we're ready for the real deal. Let's dive into the core building blocks. This is the lingo you'll need to know to actually talk about Kafka. First up, the topic. This is the main way you organize things in Kafka. Just like that payments PO box in our analogy, it's just a name for a stream of related messages. You could have a topic for orders, another for user clicks. You get the idea. Now, here's the clever part. To handle a crazy amount of data, a topic isn't just one long list. It's actually split up into smaller pieces called partitions. Going back to our analogy, think of it like having multiple mail slots for the same PO box. This lets lots of mail carriers work at once. Each partition is its own perfectly ordered, unchangeable log of messages. And this is the secret sauce to how Kafka gets so fast. It's how it achieves parallelism, letting a whole team of consumers read from different partitions of the same topic all at the same time. Okay, this is one of those things you absolutely have to remember about Kafka, so listen close. Kafka guarantees the order of messages within a single partition, but it does not guarantee order across the entire topic. So if two messages land in the same partition, you can bet they'll be processed in that exact order. But if they're in different partitions, all bets are off. And believe it or not, we'll see in a minute why that's actually a good thing. So let's do a quick recap of the key players. You've got the broker, which is just a Kafka server. You usually run a bunch of them together in a cluster. The app sending messages, that's the producer. The one reading them is the consumer. And if you want to scale up your reading, you can have a team of consumers working together, which we call a consumer group. Kafka is smart enough to make sure that each partition is only being read by one consumer in that group at any given time, so they don't step on each other's toes. Okay, we know the pieces. Now let's see them in action. Let's trace the journey of a single piece of data as it flows through the whole system, from the moment it's created by a producer to when it's read by a consumer. When you zoom out, the process is actually really elegant. It's just 3 steps. 1, a producer sends some data. 2, the broker gets it and saves it safely. 3, a consumer comes along and reads that data whenever it wants. The most important thing here is that the producer and consumer never have to wait for each other. They are completely, totally decoupled, which is a huge deal for building resilient systems. Okay, remember that ordering guarantee we talked about, how it's only within a partition? So how do you make sure related messages are processed in order? Well, that's where the message key comes in. It's super important. When a producer sends a message, it can attach a key to it, like an order ID. Kafka is smart and uses a formula so that all messages with the exact same key, like all the updates for order 123, are guaranteed to land in the same partition. And just like that, you get perfect ordering for that one order, while still processing millions of other orders in parallel across other partitions. It's kind of brilliant. So when your producer sends a message, you probably want to know, did it actually make it? You control this with a setting called X, short for acknowledgements. Think of it like a dial for safety versus speed. If you turn it to X equals 0, you're basically saying fire and forget. It's super fast, but you might lose the message if something goes wrong. Great for logging, where losing one message isn't the end of the world. The default is X equals 1, where the main server says, yep, got it. But if you're dealing with financial transactions, you crank that dial all the way up to X equals all. This means you wait for the main server and all of its backups to confirm they have the data. It's a bit slower, but it's as safe as you can possibly get. All right, let's get to the thing that really, truly separates Kafka from a plain old message queue. I mentioned it before, but it's so important we're giving it its own section. We're talking about Kafka's superpower, data retention. See, with a normal queue, once a message is read, it's gone. Poof. But Kafka holds onto its data like a logbook. And you have two main ways to control this. First, there's simple time-based retention. You just tell Kafka, hey, keep everything for the last 7 days. This is incredible for replaying events. Imagine a new app comes online. It can literally go back in time and process a whole week's worth of data. The other method is log compaction. This one's a bit different. Instead of keeping all the messages, it only keeps the very latest message for any given key. This is perfect for stuff like a user's current shipping address. You don't care about the 10 old addresses, just the most recent one. Okay, let's bring this all together. We've talked about what Kafka is and how it works. Now for the million-dollar question. When should you actually use it? Because as powerful as it is, it's definitely not the right tool for every single problem out there. Here's the checklist. You should think about Kafka when you need to handle a massive fire hose of data, when you need that data to be stored safely and, this is key, be replayable, when you have lots of different apps that all need to read the same stream of data independently, and when you need that order per key guarantee we talked about, but at a huge scale. If you're nodding your head to these things, then yeah, Kafka is probably a great choice for you. But let's be real for a second. If what you really need is just a simple to-do list for your apps, a work queue where a message is do this task, and once it's done, it's gone forever, a classic message queue is probably a much, much simpler option. Using Kafka for that would be like using a sledgehammer to crack a nut. It's just overkill. And hey, one last little piece of practical advice. If you do decide to use Kafka in production, what's the magic number of servers or brokers you need? The answer is 3. You always want at least 3. That's the minimum for making sure your system can handle one of the servers failing without everything grinding to a halt. So there you have it. We started with a simple post office and ended up with this powerful concept of a distributed, unchangeable log. It's more than just a pipeline for data. It can be the central nervous system for an entire organization. So I'll leave you with this question. Now that you get the idea of this universal, replayable history of everything that's ever happened, where else could a pattern like that be a total game changer?